One of the biggest concentrations we've had in the recent months is working with Open Compute. So we've become assessed by Open Compute as being Open Compute Ready, and they're launching that whole marketplace solution provider for Open Compute Ready at their summit in San Jose on Thursday and Friday of this week. That's been really good for us because we sit, as part of that, we sit on the data center project board. So we get monthly calls where we interact with all of the providers, users, and solution providers. So we actually get to hear about what's happening in the data center market, and we can try and cherry pick from that as to what is going to be the sort of leading solution going forward. I think Open Compute as a platform is going to be a while before it's adopted across the board, but clearly people like Facebook, Microsoft, and the larger sort of hyperscalers are all using that type of equipment, mainly because it drives down the bottom line. So I guess the biggest driver for efficiency has been the cooling system. That's been the real focus to drive down PUEs from maybe 10 years ago when they were definitely at the sort of 2 level. So for every unit of electricity used for the IT, you had another unit to drive the cooling system. So our current PUE is at 1.2. But one of the key things we've learned is that because data centers are often not fully loaded, they're often somewhere in the region of 50 to 75% loading. We've actually managed to develop a response from our PUE that actually dips during that mid-range. So we actually go down to about sort of 1.15, 1.16, and that really drives huge benefit for our customers. So going back, as I said earlier, trying to reduce that PUE is such a driver for the bottom line, and that's built into the OCP model as well. Energy probably, in relation to the other fixed costs, rentals and so on, probably accounts to 40 to 60% of the total cost of operating a data center, depending on what pitch they are and volume of space they're taking. So if we can reduce that PUE from, say, a 1.6, 1.7, which is the last benchmark figure from the Uptime Institute survey, down to a 1.2 even, if we look at that over one of our 8.8 megawatt buildings, if that was running at 75% load, we would save the customer about £3 million of electricity annually. So I guess the real key there is actually providing the right resilience that they need as a service, not a one-size-fits-all. If you go back historically, people have generally done a 2N system, or probably N+1 on cooling, but 2N electrically. It may be the easiest to manage, but it involves a lot more capital investment. That may not always suit the model that the customer wants. So if they've got more resiliency in their applications, it actually works better if you give them a different architecture. The flexibility that we've got in the building that we've put together allows us to configure that electrical infrastructure to be N+1, either on a catcher system or a redundant system, or even a full 2N system. So we've got that flexibility to address the actual requirements. So it's having the flexibility or the innovation in the design of the base infrastructure that allows us to meet people's requirements.